Erik Cheng, sir, thank you for coming on.
Yeah, thanks for having me, man. Appreciate it.
Yeah, are you kidding me? It's always a honor, to be able to put out this content that helps out people, and you were willing to share some info with the people listening and watching. So we go back a little bit. We were just talking, 5 years?
Yep. So we worked in assisted living together.
Yes.
Yep. And the thing is, I really like this show because it's like, I'm one of those victims, I spent like 9 years just to get my bachelor's because I couldn't figure out what I wanted. Yeah. I spent like the first maybe 4 years waffling.
In college or?
In college. Trying to figure out. Like I had a goal, but I didn't. It was like, I was like coasting confident kind of thing. Okay. Yeah. I wasn't eyes on the prize for sure.
That's awesome, dude. Honestly, it makes me so happy that everybody else out there can relate, because the first thing why this kind of happened was because I'm like, dude, what would be beneficial, like actually bring value to people? And I thought I thought about myself and my siblings and stuff, and I'm like, dude, everybody's wasted at least 2 years in college. At least. I mean, like, everybody's like, we're taking prereqs and stuff. But if at the beginning of college you knew what you wanted to be, like your prereqs would be much more directed
and streamlined. And like once you figure out like you have that focus, then it's like, I know what I need to get to at the end, and I know the steps to get there, kind of thing. And
exactly.
And you're way more streamlined.
You're more motivated in your classes. You're not just taking them just because. Dude, that's awesome.
Because you don't know if it's gonna get wasted. Like when we met. I was thinking I was going to be in the medical field. I was doing pre-farm, getting like all my biology out of the way, all the chemistry, and I didn't end up using it, kind of thing,
It's crazy because we both worked in assisted living. I thought I was going to be in the medical field. You thought you were going to be in the medical field.
And I am probably one of the furthest away from the medical field.
Yeah, I'm managing construction. You're... Okay, so what's your title?
Okay, so my official title is PLC Applications Engineer. Okay. And a PLC is a programmable logic controller. You could think of that as like a kind of a slower computer. Controllers work in the way that you and I work. So for example, if we are driving, and we see a green light, we take in that information, we do logic with it in our brains, and then we have an output. So in that instance, we take in a green light, our mind says, okay, we're safe to go still. And then the output is we can keep our foot on the gas pedal. And so as soon as a red light comes, then we take in that information, we say, hey, we're gonna stop soon. Or it was a yellow light. So we're preparing to stop. Then we can tell our bodies to say, hey, start pressing on the gas or the brake pedal. And then we stop. So that's how it programs in a PLC, a controller work.
Okay, I don't know anything about this. So this is slower than a regular computer?
Well, okay, it's just a controller. So like if you were to program when your sprinklers come on, that is a controller. So what I'm doing is I'm programming those kinds of things with code virtually for industrial applications. So industrial as in like infrastructure, like residential has pressure in your water, right? I'm the guy that controls what your pressure is. And
in the water treatment or in the water facilities?
So everywhere, basically.
Okay. Bring me some life examples, like where, because honestly, I have no idea about this job.
No, it is very broad. Very broad. So, for example, one thing I directly control, one is distribution. So, in the house, your sinks, your shower, all have a pressure. And let's say it's like 75 PSI for the grid. Everyone in your district has this pressure. And so if everyone wants to flush at the same time, all of that pressure is going out. We need to find a way to refill it. So I have a controller programmed that says, hey, if I sense that the pressure just went down, I'm going to start some pumps to build pressure back up in your water.
Wow.
And that's what we're doing.
Thank you,
Stuff
Erik.
like that.
Thank you for... So you're not responsible for the power being turned off at people's houses.
I'm not.
You're not.
But
okay.
People in my degree are.
Okay.
Because I graduated with a bachelor's in electrical engineering.
Mm-hmm.
And so there's lots of different ways you could go with that. From Sac State, a big one is to go into power.
Okay.
And the reason we have power outages is because of safety, you know? Like if a tree hits a power line, something lights on fire.
Yes.
Kind of thing. So that's why.
Okay, so since you know a little bit about that, what is the politics behind this?
Ooh.
Do you know?
Straight over my head.
Okay.
I am
because I've been hearing
I'm
two
very
sides
uninformed about politics.
Okay, because I've been hearing two sides about this power outage where California's putting too much regulations on the power companies, so now they're just kind of playing it extra super safe.
Oh yeah,
which makes sense. But since you don't know, we'll change the topic then. Okay, so you program things like the sprinklers. For example, just so we understand, like our sprinkler system at home, which like every homeowner or renter programs their own sprinklers, like the days.
Yeah, exactly.
So that's like the simplest.
Same kind of thing.
Okay, that's like the simplest. I'm sure what you do is a little more complicated.
It can get more complicated, but I would say a lot of it is very simple. Like 5-year-old can program it, like have the fundamentals to program it kind of thing. So one of the, I would say most common kinds of jobs that we have are like, for example, we know that Northern California gets the water and we need to send it down to Southern California.
Okay.
And we also know that water tends to flow downhill. But there are mountains.
Yes, okay.
So the reason we can get it to Southern California is because we pump it back up.
Okay.
So one example is it's called a lift station. And basically we just pump water upward so that gravity can take it downward.
Flow down. Okay.
Yeah, so sometimes we'll have wet wells or wells that fill up because water is flowing into the well. We'll read a level, and when the level gets to a certain height, we're going to say, hey, we need to drain this level down by pumping that water upward and then let it flow down again.
Okay.
So that is the on condition. We'll do logic. We'll tell the pump to turn on again. The water will flow out of the well upward and then travel back down. And so that's basically it. Yeah.
So do you work with dams? Like
I also do dams. Yes.
Folsom Dam here.
So the thing about automation is that it applies to systems in general.
Okay.
No matter what kind of system that is. If it's water, then you're thinking like irrigation, parks and recs, rivers. I've done dams and fish ladders.
Okay.
So like things that help fish travel upstream.
Like the salmon and around here. Okay.
I also do wastewater.
Okay.
So sewage that leaves the house, that works through the whole process of like getting the water out, cleaning it, disinfecting, having good bacteria break things down and kind of filter out the water before we do chemical injections on it. The whole thing.
So you mentioned automation a little bit, and it's actually a very good example because I think more than ever now, people are afraid of automation. And it's kind of understandable because there's a lot of jobs going away to these systems. But at the same time, there's people like you that the systems or this automation wouldn't work without. Correct?
That is true. And there's a lot of safety concerns with it. So if you think about it, there is a city out of state that we're doing a project for. And historically, there's been one guy that checks the chlorine in your water for a whole city.
Wow.
And he checked it once a week. And he was like, oh, it looks good today. We'll leave it.
Yeah.
But if you look at the trends for it, sometimes it spiked too high. Sometimes it doesn't meet standards.
Okay.
So one thing that, and I'm sure he's doing the best he can. He's one guy.
Yeah.
And he has a whole city to take care of.
Right.
But he does the best he can. What automation does is it makes it consistent. and it makes it scalable.
Right.
So if you have one system, you can multiply that out. It'll work exactly the same way, kind of thing.
So it's not necessarily taking away a job. It's helping to be more, like you said, consistent and to make our jobs easier or better.
Absolutely. Yeah. The last thing is that makes it easier for the operator. That one operator can look at the whole entire thing from his phone now and say, hey, this is okay. He could just take a 5-second peek at it whenever he remembers kind of thing.
Okay.
And say, hey, I'm okay on this dosing, or no, I need to increase my dosing set point.
Okay, like so you said you got your bachelor's?
In electrical engineering.
In electrical engineering. What made you go into like this specific automation, or is this something you...
So this one kind of creeped up on me.
Okay.
I got into electrical engineering because I thought I still wanted to be in the medical field, which is weird. Yeah. I wanted to be a biomedical engineer.
Okay.
So I wanted to do like prosthetics or like, what is that? Like crowns for teeth and stuff. Yeah. And that's the kind of stuff I wanted to do, is like still help people.
Yeah. And
once I got into the electrical engineering field, I was like, wow, I could do power. That would be awesome. It's super safe. Job security, great pay. And career fair came up my senior year, and this company snagged me. They're like, hey, do you want to be a PLC programmer? And I was like, sure, what's that?
Yeah.
Kind of thing. And like it's kind of like one of those things where the more you describe it, the more questions there are.
Yeah.
Until you actually
experience it.
Yeah, either get your hands on it or see it for yourself, kind of thing. You know?
So what's your typical day at work? Do you work Monday to Friday? How does your schedule look like?
So we are a 24/7, 365 kind of company.
Okay.
Because if we always need to have water. Right.
Everything needs to be controlled.
Yeah.
Okay.
If there's a huge depression and people stop buying underwear or like new cars, they cannot live without their bathroom, or they cannot live without clean water.
Right.
Kind of thing.
Okay.
So all that kind of stuff needs to work still.
Okay.
It's very interesting. My job has different projects. I'll have maybe 7 projects at a time because they all have different timelines.
Okay.
Basically, a end customer, which is like maybe a municipal or a city, will have money from the state to improve stuff, like if it's the Natomas levee or if it's a bridge.
Okay.
Or if it's just like transportation and streetlights kind of thing. They'll get money and they'll contract out an engineer to like design what it's going to look like.
Okay.
Then that'll go out to bid for someone to say, hey, I can make this happen for this amount of money.
Okay.
And then they hire us to put the whole thing together and make it work automatically.
Okay.
So what my job is it's documentation. And it's basically, when I program, it is programming, but it's kind of like programming with Legos, where you have pieces that do things and you stack them together to make things work in a certain order. Kind of thing.
Got you.
So I'm programming, doing documentation, working in the office about 70% of the time. And then the other 30% of the time, I'm out and about in the field, kind of starting these projects up and watching them to fruition.
So correct me if I'm wrong, most of this is like new projects, like new construction, new facilities? Like,
it just depends. Because sometimes it could be a lot of new construction. Sometimes it's just improvements on existing.
Okay, gotcha. So maybe they're changing out the water tanks or the water or the generators in like in a big building in downtown Sacramento or something. Okay.
Or if, like for example, I'm starting up a new community where they have lakes in their community.
Oh,
like
lakes.
Small lakes.
Okay.
And they're circulating water through. Or if there's a huge storm and they all overflow, then those pumps can instead send all that water out to the storm drain.
Okay, gotcha. So,
so a lot of different things.
So you're like very behind the scenes, I feel like. And I personally never thought about the guy that, wow, how did these lakes are always at the same level?
Yeah.
That's because people like you are like,
someone has to let the water out of the dam.
Communities have ponds and fountains and all this stuff.
Yeah.
That's
I'm in
cool.
like one of those jobs where like if you don't hear about my work, we're probably doing a good job.
Exactly. Exactly. That's cool. Keeping things under control.
Yeah.
We definitely underappreciate, I think, those people because you never see them, and they're never on the news unless they're screwed up or something.
Yeah. If like a wastewater plant goes bad, you know about it.
Yeah. Oh, definitely. I mean, you can smell it.
Right.
So, is there any stories that you can share? Was there ever like obviously they said whoever the company asked you, do you want to be a PLC?
Yeah.
PLC. So you're like, okay, let me find out a little bit about this, and then you
call them programmers.
Programmers. Okay, so you want to be a programmer, and then you got the job. You started, and you're like, oh wow, this is. Were you amazed by anything, or you're like, wow, this is what I get to do, or this is how this works? Like for example, someone that wants to be a programmer, maybe something similar to what you're doing. What are some things maybe that you didn't expect?
Just like the magnitude of the diversity of projects. I did not expect. I thought, oh yeah, we're going to do like maybe some water plants, some wastewater treatment, but I didn't expect that we would do like dams and bridges and transportation lights and like anything that's automation we could potentially do. We could also do solar.
Okay.
Like that has a controller. In fact, my senior design project was using solar panels.
Okay.
And that was super cool. If you think about the company Tesla, Tesla has robots building cars.
Yes.
A PLC is used to program those robots doing it.
So
same thing with like cereal.
Yeah.
Same thing with food and bev. Any like Coca-Cola companies.
Any manufacturing.
Yeah. Those are all PLCs.
Wow. So that's actually now that I think about it, that's a lot of jobs.
Yes.
So at the same time, even though these machines are taking away positions, new positions are created because these machines need to be taken care of, maintained.
And they're taking away jobs that are like extremely dangerous to be around. And especially at the speed that they're doing it. Like so there's a lot of like machining accidents that happen that are being
that cost lives, and now it's either your arm or a robot's arm.
Yeah.
For example, if something goes bad. So that I think that's pretty cool. What made you you said you wanted to first be in the medical. You want to be a medical engineer, right?
Well, I wanted to be a pharmacist first.
Okay.
Pharmacy, I mean, the job that they do.
Why did you go from pharmacy to engineering, electrical engineering?
Yeah. Okay. So I worked at Atria for about 6 years or so.
Okay.
That's a place that you could get stuck in.
Yes.
I went from there to a pharmacy, and I was still working with people. It's fantastic kind of thing. And that's when I started thinking, man, I could be like pushing technology. I could be using like my creativity to change the world kind of thing. And I'm not trying to bash the medical field at all because it's fantastic. That's very special people working those things.
Yes.
But I felt like I was getting stuck just like taking care of people. Yeah. And no one goes to a pharmacy because they feel good, because they're happy,
Exactly.
And so it was a little draining. So when I switched, it was because I wanted to kind of get into the technology, like the bleeding edge of technology kind of thing.
Okay, that's awesome. So you said you wanted to be more like prosthetics and or something to do with dental, or like
like
making crowns.
Crowns are taking like X-rays of the teeth and like rebuilding it.
Okay,
that's something that you need to do in 3D modeling kind of thing.
Oh, okay. So that's more. That's programming because you're using a computer. Then this company approached you. What school did you go to, if you don't mind me asking?
Sac State.
Sac State.
Yep.
Okay, so there's students in Sac State that are maybe doing the same thing you are. I personally know people that want to be electrical engineers, and the people that I know that I want to be electrical engineers, they don't even know what kind of jobs are out there.
Right.
So,
and there are a lot.
So maybe you can share with us what kind of jobs out there. You chose one, or the job kind of chose you. Mm-hmm. What's the potential of an electrical engineer?
So with electrical engineering, you're giving the knowledge to like design things and to troubleshoot. So you could go into like circuit board design. So if you wanted to go out of electrical engineering with your degree out to Silicon Valley, you could join a startup and they will make devices. So like if you wanted to design the hardware for like smartwatches or something, or anything that's startup related, like a bicycle, like a smart bicycle, smart anything. You know?
The scooters around San Francisco or Sacramento,
There's
the bikes.
circuitry on that, and whatever makes it smart is mostly electrical engineering.
Wow. So now that I think about it, that's kind of like the job of the future.
Sort of.
Because everything's moving. I mean,
every branch of engineering thinks that until they think about the next one that would come after them, until it gets to like completely virtual. So like it'll start with civil or like structural engineering and civil, and then mechanical engineering, and then electrical engineering. So like, well, we're doing electricity, so that moves faster than like hydraulics. Yeah. And then computer engineering are like, well, you're doing hardware still, and we have processor speed. Yeah. And then computer science majors are like, well, I don't even talk English anymore. I just talk programming language, kind of thing.
That's great. So is there like an internal battle between engineers?
Yeah, there really is. There's a sibling rivalry. All of them are very important.
Yeah.
Don't get me wrong.
Dude, I mean, you don't have a structure to put your electricity in, to put your machines that get programmed in. I think it's very, very closely, like you said, they all work with one another very closely.
Yep.
What would you recommend? So you're one of those special cases that wasted their time, or not wasted. You weren't sure what you wanted to do. You were trying out different things. Someone in school, and they want to be an electrical engineer. What would you recommend? Maybe they're in high school. Like, what can they expose themselves to kind of be sure that this is what I want to do?
So I think that exposure at a young age is like really good. But if you don't have that, like for example, I'm pretty sure 5-year-olds, 6-year-olds can be taught the very basics and fundamentals of programming.
Yeah.
And a lot of programmers, like computer scientist programmers, like do like C# or JavaScript and those languages can learn it.
Okay, I have no idea what C# and JavaScript are.
Those are just programming languages.
Okay.
Just like English and Spanish, but for computers.
Okay. Yeah.
So, those, like a lot of people are getting jobs being self-taught those things. And there are a ton of like free online resources for learning programming online, to teach yourself. And just like the fundamentals, follow through all the way, from platform to platform. If you're programming on a computer or if you're doing an industrial application, those concepts still exist.
Now that you mentioned self-taught and people get jobs by being self-taught, it kind of reminded me of, I don't know if you watched the interview with Joe Rogan and Snowden.
No, I did not.
Okay, that was an amazing interview. Yeah. So Snowden kind of shares about himself, how he was growing up and he hated school, but he was very good with like technology, and he taught himself that's how he got his first job, working for some lady, and her husband worked in the CIA or FBI or something like that. And anyway, it just trickled from there.
Yeah.
But you were saying exposure, and kind of that's what he did, exposed to something he loved and taught himself. And with the world moving into more everything electrical, being electrically engineered and all in the future, it's so easy to expose yourself to these language and teach yourself. And I'm sure, especially now, the young age, they're already exposed to all this new technology and
I have a 2-year-old nephew that is like knows YouTube inside and out.
Really?
It's wild. It's kind of terrifying. Yeah.
I mean, it feels like they're almost automatically growing up to be like these electrical engineers or programmers, because they know like all the inside. like kind of like, I don't know if I can say our generation, but maybe the generation prior to ours. Like I feel like my parents, all the men and some of the women grew up knowing the engine because that was kind of like the new fascination for their generation. Everybody's like, oh, I know what an engine is, or the basics of it.
Yeah, absolutely.
This generation,
I didn't fall in that category. But
you didn't?
No, I wish I did, but
JDM.
No, but yeah. Seriously, the same thing though with phones. Like they're immersed in technology already, which is kind of scary because like I feel like when I have a kid, I want to give them like puzzles only on my cell phone. You know?
It's not gonna work.
No.
If you want to give them puzzles, just give them a real puzzle.
Yeah,
or Lego sets.
Yeah,
Lego sets work because they're like you said, your nephew is so smart.
Mm-hmm.
Like you tell him, okay, you can only watch puzzles. Next thing you know, I mean, they know how to use everything. They'll hack.
Yeah,
they'll hack your like. My kids will hack my phone, figure out my password. I don't know how.
Yikes!
It's crazy. Yikes. And so these kids growing up now, this generation is exposed to so much technology, if I can say that. It's like a natural instinct for them. Just like the generation prior was a natural instinct to be interested in automotive and all these industrial, you know. So now it's everything industrial is moving to being programmed. And so it is a good thing in a way because it's not like they have to make this major leap of, we were taught everything industrial or manual and now everything's technology. So it helps them out
a
little bit.
And so there's a product that is very popular and it's open source. I'm pretty sure it might not be open source. But have you ever heard of like Arduinos? Arduinos are just this little $5 controller and like you can buy them for like $20. In fact,
it's a $5 controller for $20.
Oh yeah. That you could get the whole kit for it. And it comes with like wires and the software and like a little breadboard so you could do your own little wiring. And it's basically like building your own little circuit, but in Lego form kind of thing.
Okay.
You know, they give you the schematic diagrams. You're only playing with 0 to 5 volts kind of thing to say, hey, when I flip the switch, I want this LED to turn on and change colors.
Okay.
Or I'd like this little piezo buzzer to play me a song kind of thing. You know?
Nice. So that's a good way to expose.
That's stuff 5-year-olds can play with.
Okay.
Yeah. And so like I didn't play with it when I was 5-year-olds. I played with it when I was like 22 kind of thing, you know?
I mean, so that is very important. I'm glad you shared that because now that I think about it, I hated science projects in school. Like I remember elementary school, I remember my science project, dude. It was such a failure. So I made this so dumb. Like back in school, they used to have like this eraser that looked like a pen that you push out, and it was like a long eraser.
Okay, yep.
So I thought I was so creative. I took out the eraser and put a pencil in there. Now that I think about it, it was one of the dumbest things ever because a pencil stays a pencil no matter if you push it out or not.
Yeah.
So, but now that I think about it, like I definitely learned from that because I will push my kids in their science projects to experiment with different things because that's part of that exposure and will probably help you, make a choice in either your career or what classes or what school you want to go to, stuff like that.
Yeah.
What classes would be good classes to start with in college?
All of the math ones.
Dang. Okay.
That sucks.
Some people hate math.
Yeah. No, but I was working in Atria with a lady that you know also. That started at the very fundamental arithmetic math.
Okay.
And finished calculus before I finished calculus.
Wow.
Yeah.
And did she come from a different country?
She did. She did. She came from a small village.
Yeah, obviously it was hard for her as well. So if she can,
but it's like that determination kind of thing.
Amen.
If you want it, you want it.
Yeah, that's true. So if she can do it, anybody can do it.
Yeah.
So don't be discouraged by numbers.
Yeah. And like once you understand the concepts, each class after is just one little thing on top of what you've been grilled on already.
Okay.
And it sucks because it all seems very abstract. But when you get into engineering, all of those things that you learned before have application now.
So they do have application.
Yes, and you never think that.
No, you don't, because usually like, why am I memorizing this book? I'm never going to use it.
Like, why do I ever need to do long division? You know, that's never gonna be a thing.
I just actually saw a meme about this where someone says, "When am I ever gonna use this long division?" And then this mom takes out her kid's homework and she's using long division to teach her kid.
Yeah,
that's the only time she's using long division.
That's funny. Yeah. So I just did a presentation for my whole department about doing long division through what is it, like computer language, and it's like it works exactly the same except you don't use regular numbers 1 through 10. You only use zeros and ones. It's crazy.
Dang, dude, you're way too smart for me. I would not.
It's like just knowing another language. I only know English, so yeah.
So
there's only so much to say about that.
Now that I think about it, I mean, just like learning music, right? Learning notes and stuff like that.
Same exact thing. Once you know rules to it, like, for example, music, if you know like keys to play in, you could just freestyle. Right. And just like play like jazz or something, you know? Nothing that has like formal like music written for it. Same thing. You know the rules for it.
That actually simplifies it a lot. It's not as...
Same thing with programs.
As long as you know the formulas and how things work, the rules of things. Okay.
Yeah, so same thing with programs. It's like building a car, you know? You don't just buy like each piston for your motor. You know, you buy the whole motor. Right. And you're not inventing the wheel anymore. Yeah. So things exist for it, and you just put them together in a way that makes sense. You don't put the motor upside down in the passenger seat kind of thing, you know?
Right, there's a spot where it goes.
Yes, exactly. So things like
that. So
it's
not... So when you're becoming an electrical engineer or a programmer, you're not really reinventing everything.
No.
Because...
People did that for us.
Yeah, you obviously just use all these pieces that they have. You learn to put them together and to use them. But I'm guessing in school, you're probably learning all the fundamentals and the basics.
You're grinding it so that you can understand the concepts behind it. And it's interesting because electrical engineering, and I would say any engineering school in general, it loads you down with useless equations that you will never use. But on the other side of it, it teaches you how to think. Kind of thing. It teaches you how to run into problems and how to handle them and how to troubleshoot them. And that's probably one of the most important things. The other one is that the curriculum is really, really hard. And I don't know if that I could have done it by myself. So something that I had to come away with was networking really hard. And so like banding together, leveraging other classmates as resources is something extremely valuable in college and also in industry.
So is this when you went to Sac State? Did you take prereqs before you went into Sac State, or you just went to Sac State?
Yeah. I went to American River College for all of my prereqs. I 100% of the time would do that over the exact same way. I would go to JC for all of my lower divisions before I jump up to Sac State.
Obviously, one is it's cheaper. And two, for some people, it's closer.
And you're not fighting for classes as much because everyone wants to start freshman year at a 4-year university. I had very good luck with my teachers at my junior college at ARC. I had a fantastic circuits teacher that I took some of his methodology and brought it to Sac State, and they're like, I didn't know you could just use your finger to follow things and it works like that.
Oh, really? Like super basic stuff?
Yeah. Just like little tips and tricks that like old electricians know, you know?
Nice. Yeah, there's that. And actually today at work, we were talking about some stuff with layout. And at the end of the conversation, we're like, wow, the thing that works the best here is like this old layout trick that nobody uses anymore, but
like
it'll
tribal knowledge kind of thing.
Yeah. But it's almost like this is wisdom now, you know, because it's nobody uses it, but it's so valuable. Are there like programming or electrical engineering like associations or networking groups?
Yes,
that people can join.
National kind of associations. One is IEEE. And that is a National Electrical Engineering Association that kind of aggregates all of these doctorate level and like master's level thesis and documents and things on that are like cutting edge technology, like drones, you know, like quadricopters and military, like deep AI, all of that kind of stuff is in there.
Awesome. Were you ever interested in like all this, maybe going to become a military or working for some crazy agency or?
I am not allowed to talk about that.
Okay, we'll leave.
I did used to work for.
Okay.
I can't say that. Never mind. I can't work.
That's fine. Okay, I'm not gonna tell you anything else.
I will keep my resume for NASA though. I will keep that out there.
Dude, that would be probably super interesting. I mean, or SpaceX.
Yeah.
SpaceX. Oh, are they still hiring?
I'm sure they are.
Yeah, always.
A lot of those big companies. So, you know, what's very interesting about my company in general is that, and you'll know this from any company. Like, if you have great coworkers, then you have a great job, kind of thing.
For sure. Yeah.
It makes it so much easier. And if you have a great like manager, then it also so. I work for an ESOP where we're all employee owners, and I kind of like compare our company all the time to like bigger tech companies. And I went on a interview, like a hiring tour where the manager of a big corporation was taking me around, and I told him where I used to work, which I'm not allowed to talk about. And he was like, "Whoa, could you get me hired there?" And I was like, "Wait, are you the manager? Like, you shouldn't be saying stuff like that." And he was like, "Well, it kind of is not great here because it doesn't matter if you are 20 people in your group or 200 in your group. There's a top 10% within your group that is eligible for promotions, and there's a bottom 10% that is eligible to get fired. And so that kind of like fosters this cutthroat kind of pitting coworker against each other." Really? Backstabby kind of thing. And it's like supposed to motivate people to work harder. But like it doesn't do anything for camaraderie and morale. And the other way, like the company I work for currently, we're all employee owners. So the better you do,
the better the company does.
The better the company does, the better your coworker does. So it kind of encourages the other way. So instead of us like holding secrets from each other, we go over to each other and I'm like, "Ruslan, I need help with this problem. This is what I've tried." And then you'll be like, "Oh, have you thought about this way?" And I'd be like, so we'd spitball ideas back and forth, and just like that.
Like your success becomes everyone's success.
And so everyone is very eager to help you because
that's awesome.
It helps them also.
So that's awesome, dude. So someone maybe that finished school right now and they're in the interview process. What, like, say I'm looking for a job, right? I'm a programmer. What can I be looking for in a company where I can maybe recognize these things ahead of time?
Okay, that's very interesting. Yes. So in the interview process, that's one of the things I like to like push myself towards is like getting into like the interview process for perspectives and like training them up. And that's why I think this podcast is really cool, because you want to like streamline the effectiveness of someone's time.
Right.
And the same thing with me. Like when I have a new hire, I want to make sure they're up and running and not kind of feeling like they're wasting their time. So like in an interview, I think that if you're in an interview for a company, you could just look at other employees
and like, tell by
and see, like, is there a glow? Like, what is the color like in the energy of like, because I used to work for a government and the energy was like gray. It was like cold. You know?
Yeah.
And so for our company, it's like, that's one of the things that really sold me during my interview, is that like everyone I talked to seemed like they were happy to be at work.
Just like the culture of the company, you can tell from the people interviewing you.
Well, just people walking around too. They'll be like, "Hey, good to see you here," kind of thing. And I was like, "Oh, thanks. I don't work here yet."
They seem more friendly than. Well, okay. That's
the other thing is like during the interview process, it's like my manager knows that we all come from the same education, basically. Okay, so he's more doing like a personality kind of match. Is he gonna fit? He or she gonna fit with the rest of the department? How are they gonna do out in the field when they're face to face with the company, like customers and stuff?
Okay.
Yeah. Are they pushing themselves to, like, do their work well and on time and
just self-motivated and all that type of stuff. Okay, so if you're looking for an interview, it's that's actually very important that you say that, because I feel like, and many people in the older generation feel like, oh, these millennials or these maybe the generation under us, they're so ungrateful, they don't want to work for their money. But I would have to disagree with that. Because yes, there are some people in those cases, but most of the people are willing to work for the money. And obviously, if you get a degree in something, then you know it takes hard work, and study to get something in return, a degree.
Yep.
So just be prepared to show probably the company that's looking at you that, hey, I'm ready to work hard, I'm ready to improve on myself, and be valuable.
Yeah.
Be valuable to the
Absolutely.
company. I was talking to our engineer. He was saying we've kind of think about this wrong. Like sometimes when we get a job, we're thinking, oh, how much money am I going to make an hour?
Absolutely, yeah.
But what we should be thinking is, how much value can I bring for this company?
Yes.
And how much is this company going to value me?
That's exactly what I was. Yeah, I love that point, because it's like, how hungry are you to where like you stop caring about like yourself as an individual and like thinking about your future with this company and growing together kind of thing. So that's like one of the things that during my interview I told my now my boss, it was my interviewer. And also, you guys should do this if you're interviewing for anything. If you're an electrical engineer or any kind of engineer and you're bidding for a job, doing this will get you that job.
Okay.
Like, do research on the company, figure out what they're strong at and what they're weak at. And the things they're weak at, how can you help improve that?
Ooh, okay.
Kind of thing.
Yeah.
So I had just come from a company that worked for the government, right? And I come interviewing for this company, which is more flexible, more kind of amorphous and still rough around the edges. So I'm coming from all this structure and I'm seeing all of this and I'm like, hey, you hire me.
Yeah.
I can bring all of this, and this to our training program so that we are more efficient and we don't have programmers trying to train up for 2 years before they're very effective and you're getting your money's worth off of them. The other thing is like, I get lazy sometimes, you know?
We all do, yeah.
And I'm in the automation industry. So
I got you.
I like to automate my job.
Yeah.
You know?
Yeah.
Am I automating myself out of a job? Maybe. I don't know. But the same thing. Yeah. Consistency, scalability, ease of use kind of thing, you know? So a lot of the things that don't require critical thinking, like databasing, kind of like data entry, all that kind of stuff, click kind of thing. Let the script run. Okay. And the things, that way I have more time for things that do require critical thinking, like how am I going to make sure that these people are going to get the correct amount of chlorine in the water?
Okay.
You know?
Yeah.
That kind of stuff.
That I think those are some real words of wisdom.
Yeah.
And when we go into an interview, oftentimes, I mean, I even know myself, like back in the day when I was doing like my first interviews, I'll Google and you see all these resumes on Google, like, oh, how many languages you know and your personality traits, and all those things are good. But what you just shared is, I think, very important, is like, see how you can be valuable to the company that you're applying to. And I know my brother, he just had an interview with the fire department. And as a firefighter, they say, like, learn about the fire department, just like you were saying, kind of how you can assist the fire. If you really want that job, show that you care about this company, or do some research on the back end and all that stuff. Okay, so and we're almost wrapping up here, but are there any other things that you'd like to share with somebody that's thinking about becoming a programmer or electrical engineer? What would you say?
Yes, I have another kind of interview kind of tip.
Okay, what's up?
This probably goes for anyone, but don't oversell yourself.
Okay.
Especially on your resume.
Okay.
Because there are very smart interviewers. Anything that is on your resume is fair game to get grilled on. And so if there's something that you kind of like cushioned yourself with to try to get an interview with,
that might be
the interviewer might not know everything about that thing, but they sure know how to ask about it.
Okay, got you. Yeah.
So make sure that the things you put on, you know very, very well, and you're truthful about it, kind of thing. Because that's another thing. And interviewers can see right through like deceit too. Well, they could see, and especially in the stressful environment too.
Yeah. There's probably a reason why they're on the interview board. Yeah. They were trained to interview people. That makes a lot of sense.
So also, if you want to get into programming or anything with electrical engineering, buy yourself an Arduino. Buy yourself a Raspberry Pi. Arduinos, you could get the chip for $5 off of Amazon. Okay. Raspberry Pis are tiny little computers. Oh, not sponsored. They're like tiny computers that you could do a ton of different things with for $35.
And you could try it on, like, is this what I want to do for the rest of my life?
Right. And your investment was $5.
Yeah, not 2 years in college or 3 years in college. Dude, that's awesome.
And on the other side was what can you gain from it? You know? Yeah. You could get a career in automation.
Which is, from the sounds of it, or in the looks of it looks like it's growing.
And then the worst thing that could happen is you bought a $5 Arduino and you built yourself an RC car.
Yeah.
You know?
Yeah, exactly. So. Now that I think about it, just real quick, automation, maybe someone likes construction, right? And they're like, oh, I'll go into construction. But in construction as well, so many things are moving into automation. Like walls that used to be framed with say 2 guys, now all these walls are coming out as panels, prefabbed. You need somebody to automate these machines and program this stuff to build it correctly. So I mean, it's almost like a second career that everybody should like double major in.
It's in a lot of hands. I mean, especially when I'm out in the field, I am working side by side with construction workers. I'm working with plumbers, demolition, the electricians, the end user, and the foreman and the superintendent.
Yeah. There you go.
Hand in hand with all of them.
That's a perfect example. Anyways, Eric, I would like to thank you so much for coming on the podcast.
I really appreciate the opportunity to come on here. Yeah.
Dude, that's awesome because just like nursing, this animation job, programming, is very popular. And people have asked about, hey, do you know any engineers? Do you know any electrical programmers or anybody that does programming? Yeah. And I really didn't know anybody because I just don't do that.
Right.
So I haven't come across.
Different world.
Yeah, it's a different world, exactly. And it's kind of nice. So thank you for coming on and sharing your insight, sharing those interview tips.
Yeah.
I'm sure people can use them. And that's it.
Cool.
Alrighty, thank you.